So good afternoon everybody. This is my video lecture on elasticity. We shall be covering the entire topic. So let's start with elasticity. So basically it's about categorization of materials as elastic and plastic. Elasticity stands for rigidity. That means resistance to change in shape and size. So more rigid a body is, more elastic it is said to be. So examples are elastic out of tissue, spring and rubber. If you stretch a spring or rubber, it will try to get back to its original configuration. So there is where comes the word elasticity. And larger is the tendency to regain its shape, larger is the elasticity. Then there are another things called as plastic materials, which are non-rigid. Example, mud and putty. They don't have any tendency to regain their natural shape, so that's why they are called plastic. One more thing is steel is more elastic than rubber because it is more rigid, hence we can say that more rigid means more elastic. So this point should be remembered. Then there exists a concept of stress. These are of three types: longitudinal, tangential and volumetric. Stress is basically the ratio of force and area on a cross section under different conditions. For example, if we apply a force which is longitudinal or perpendicular to the surface area, then we call as longitudinal stress. However, the force is in the plane of the area of that particular object, then we call that as tangential stress or shear stress. There is another name to this, tangential or shear stress. Third thing is volumetric stress. So when you put a solid into a liquid, then liquid will exert force from all sides. So if we consider a very elemental area of the solid, the ratio of elemental force and elemental area is called the volumetric stress for that particular case. Let's move ahead. Next one, now we have questions based on this. So first question is about dimension of stress. So it is m1 l minus 1 t minus 2. SI unit is Newton per meter square or kg meter minus in second minus 2. CGS unit Dian per centimeter square. Then we are being given a rectangle. We need to find the area. Area is length into breadth, which is 12. Then we need to find longitudinal stress. So we need to take perpendicular component of the force, which is 20 sin 37. As you can see over here that suppose this is the area. So the force perpendicular to the area is 20 sin 37, whereas the force along the area is 20 cos 37. So for longitudinal stress you take 20 sin 37 and for tangential you take 20 cos 37. Then again we have questions based on strain. So similarly strain is also of three types: longitudinal, tangential and volumetric. Longitudinal strain is, suppose length is L, on stretching it length becomes L plus delta L. So longitudinal strain is delta L by L, that is the ratio of change in length by original length. Then for example of tangential strain, suppose this is a cuboid and its top surface is given by ABCD. The bottom surface is fixed and we apply a tangential force on this cuboid, due to which the upper surface will shift with respect to the lower surface or with respect to the original through an angle theta. So then we define x by L as tangential or shear strain, which is also equals to tan theta, and for a small angle tan theta is approximately theta. So we can say that x by L is approximately tan theta, which is approximately equal to theta when theta is very small. Similarly for volumetric strain, suppose this is volume in air V, and when you put it in some liquid, volumes becomes V minus delta V. So volumetric strain is minus of delta V by E. Next there is a question on this. A copper rod is given which has a length of 2 cm and a force acts on it to produce longitudinal stress such that length becomes 2.001 cm. Then find, first is change in length. So change in length is final minus initial. So it will be 0.001 cm. Then we need to find longitudinal strain, which is delta L by L, which is 0.001 by 2, which is 0.005. Then we have percentage longitudinal strain. So for finding percentage longitudinal strain, you just multiply the longitudinal strain with 100. That will give the result as 0.05. Next, we have a question based on tangential stress. So we need to find shear strain percentage and shear angle. So shear strain is x by L. So it is 1 by 4, which is when calculated finally gives 0.025. Percentage is 2.5%. And the angle phi, shear angle, is approximately x by L, which is 0.025. Next, we have another question on this. So we are being given a ball has a volume of 4 centimeter cube in air. When it is put in a liquid, volume becomes 3.9. Then find change in volume. So change in volume is final minus initial 0.01. Volumetric strain, change in volume by original volume, this much is percentage multiplied by 100. So next one, now we have Hooke's law. So according to this law, Robert Hooke was a scientist who worked on the relation between stress and strain, and he found that the relation is stress is proportional to strain up to a certain limit, and he call him as Hooke's law. So if you draw graph between stress and strain, the graph will be a straight line, and suppose it makes an angle theta with the strain axis. So stress by strain is tan theta, which is with the strain axis, and here is called coefficient of elasticity. Another question can be taken on this. Suppose there are three materials making angle theta 1, theta 2, theta 3. So larger the angle, larger will be the strains, and larger will be the elasticity or of that material. And lesser the angle, lesser will be elasticity, or more will be plasticity. Next is find coefficient of elasticity for a material whose stress strain graph is shown in the figure. So here angle is 37. So E will be tan 37, which is 3 by 4, which is 0.75. In next question, angle is from the stress. So if we take angle from here, that will be 90 minus 37, which is 53. So elasticity will be tan 53, which is 4 by 3, which is 1.33. Next is, we have a graph between stress and strain, and suppose the graph makes an angle alpha and theta. So elasticity is tan theta, and it is also equals to minus of tan alpha, as theta plus alpha is 180 degree. So using that, we can say that tan theta is equal to minus of tan alpha. Next is coefficient of elasticity. So we have three types of coefficient of elasticity. First is Young's modulus, second is modulus of rigidity, and third is bulk modulus. So when longitudinal stress and strain are concerned, it is called Young's modulus. In case of shear or tangential stress, it is called the modulus of rigidity. And in case of volumetric stress and strain, it is called the bulk modulus. So these are the definitions of these, and then we have certain questions based on this. The first question is dimension formula of Young's modulus, then SI unit, CGS unit. Then we have certain questions on that. So yeah. So here dimension formula is the same as that of pressure, M1 L minus 1 T minus 2, SI unit Newton per meter square. Then we have CGS unit as Dian per centimeter square. Then we have equivalent spring constant as AY by L. So from definition of Y, this will be Y. So if I take delta L as X, so F can be written as YA by L into X. On comparing with the standard equation, we have K as YA by L. Then K equivalent is proportional to a graph will be straight line. K equivalent versus a rectangular hyperbola. K equivalent versus Y. Straight line again. So these were some of the things. Let's discuss another things in the next video. Thank you. Have a nice day.